Yeah, it's just, but it's a and and so now so I'm friends with Apple because I'm trying to hire me to do her and so programs all the time. And she's not like the position is based in Seattle, but I think I can hire you. So I also just again I have this thing where I feel like the role is intense. It's like that's important out. Words, and she was like, episode, it's supposed to be San Francisco, like I think. So she's like, okay, like that's just like, you know, so like twice in a row. And so I live in New York. I live in a place called Marshall. But I sell my own which is like no small people. No, so I rent, but I also rent. I have my house, and that actually made it really helpful because like every time someone people get in the street, I'd be like, like it helps the situation. Like it's fair enough. Like people are but like, yeah, it's a different.
Hello guys, good evening. Welcome to Iceberg Meetup. Do I have your attention? Hi, good evening. Well, welcome. I hope everyone can hear me, and I'm very, very glad to see so many people attending that meetup, which is a data meetup, guys. It's not AI meetup. I do have A and I, which is Apache Iceberg. It's not artificial intelligence, but you can use Apache Iceberg for artificial intelligence as well. But welcome again to this meetup. I want to thank as well Google and ClickHouse to sponsor that meetup, and I want to just start with introducing the community, because we started around a year an Apache Iceberg community meetup here in Europe. Because probably, you know, like Apache Iceberg is mostly presented somewhere in San Francisco. So if you want to get some information, you need to fly over, which is kind of, well, probably a little bit hard for Europeans to take like a flight for 13 hours and go over to US. And that was kind of like motivation for ourselves to start a community in Europe. And look at you, it's quite big community right now. For the last 12 months, we had over 20 different meetups, over 1,000 attendees. And you actually see exactly the countries where we have already a meetup. So you probably missed some warm countries, but Barcelona is at the end of this month as well. So if you want to go for a swim, Barcelona, Apache Iceberg meetup, you need to find kind of like excuse on your boss side, explain the story, but you can do that. I'm quite sure about that. And you see like all sponsors who is actually supporting the Apache Iceberg, which is quite interesting because usually if you go like to a user group, it's about the user group on technology X or Y. But on Iceberg, we kind of trying to unite everyone, and that's quite cool. Well, it is open community, and everyone can speak at that community, which means welcome to listen to community, but we do have great speakers, and every one of you can become a great speaker as well. Well, I'm starting, you know, like at a concert, you have someone who needs to warm it up, and then the star is going to be like later. So Melvin is closing the show. Stay till the end, and you will get a quite cool presentations here. Thank you for every speaker taking that advantage, that opportunity, and be brave enough just to go and speak about Apache Iceberg. Well, I'm the first one, so I'm just going to start talking about some stuff. It's going to be like a boring topic. I'm not going to present you like how you're going to analyze a petabyte of data within a millisecond. So I just heard someone is doing like nanosecond analytics as well, which is quite cool and it's quite sexy. My topic is more boring. So I'm talking usually about the governance. I talk about backup and I'm talking about restore, everything like where a data engineer will probably say, we will solve that tomorrow, right? So let's just do something what is fun today, and that part is going to be solved tomorrow. So I'm talking about the trust infrastructure, and yeah, quick introduction. My name is Victor. If you have like any questions later on, you can reach out to me on email, on LinkedIn, and so I'm glad to talk with you about data, lakehouse, Iceberg, or whatever topic you have. Feel free to reach out. Well, my topic is BCM. Who knows what BCM stands for? Who said that? Super. Business continuity management, which is what? Yeah, if something goes wrong. If something goes wrong, so which means like we have a topic and it's quite interesting, and the topic is like, let's do an insert in a database, right? So we will just insert some data, we will run some update, maybe delete, but let's just do an insert. And the next step, we understand, oh, wrong data. So what should we do? We panic, right? So we panic and we should just do something about that. And we're trying to reach out to a colleague, a database administrator, who will just somehow restore the data, hopefully. And you know, like insert is quite fast, panic is super fast, light speed, and restore is usually, I don't know, hours, days, weeks, maybe never, which will end up with firing you and finding a new job. I don't know. So that's a quite usual scenario from my own experience, you know, like inserting data, panicking, trying to restore the table. And that's how the usual RDBMS works. But on Iceberg, we have quite interesting mechanism, which is write, audit, and publish. An audit we can get nervous, like, oh, let's run some quality assurance, let's do some, I don't know, like whatever type of a task you need to do to say like, okay, data is fine, and you want to just start doing with that data. And this is a paradigm inside of Apache Iceberg, which is called WAP, write, audit, publish. And there are native mechanisms inside of Iceberg, what I would like just to present to you today, how to achieve that. So on write, audit, publish, we have write, audit, and publish. And to achieve this, we have a mechanism called branch. So, you know, like from your GitHub, if you work on your data, you can just go and create a branch. And you can do some experiments on your branch and then so on and so forth. And then you will try to merge it and you will get a conflict and you cannot merge it and so on and so forth. And similar on Iceberg, you can go and create a branch. And then you can go and make some changes on your data. And if you find that change, then you can just go and merge the data into your main branch, which means in that time, as you work with your data on your branch, no one on the main branch is disturbed. So you don't have that panic situation. So you can just go, insert your data, delete your data, and do some stuff. And the cool part of that is you don't copy the data. So usually if you will be on a RDBMS, you will just copy the whole table, gigabyte, terabyte, petabyte. And then you will just try to do something with your data, and then you need to just to copy the data back. But on a branching mechanism, we don't need to do that. So what is actually happening here? We play with the metadata. So as you probably know, on Iceberg, we have like metadata and data. So data is a parquet, metadata. Today, it's a metadata JSON file, it's manifest list, manifest files. In V4, we have a different structure, but let's just see like how it looks today. So let's assume I do have my initial state on the main branch. Is it good to see? No? No? Like that? Better? Yeah. So we have a catalog, and that's something what Lakekeeper does, and that catalog is responsible for the metadata JSON file. And then we have our arrow files, we have manifest, and then we have a parquet file. Now I will create a branch, and that branch does not copy any data. It's just a simple metadata information change on Iceberg. Then I do some writes, some changes on my branch. And in that time, no one is affected on the main branch, so everyone can just go and run their queries. So all fine. More changes still on the same branch, still not panicking. And then I can go and make fast forward, just merging the whole data state to the main branch. And at that point, everyone can see. But you don't want to panic, right? So, and therefore, there are additional mechanism on Iceberg, which we call tag, and that helps us to do some different thing, which is kind of like a backup strategy, rollback, where we can say deploy, monitor, and rollback. How tag work? It's kind of similar, right? So what we have, we can create a table, we can create a tag on a table, and then we can actually keep it for the later on. And even if you run expire snapshots on Apache Iceberg, that tag will survive for the later operation. Then you can just go and do some changes. So same situation here. We have our table. We will create a tag, no data copied. We can do create a branch. We can do some changes. And then after some merge, what we can do, actually, we can just go and expire snapshots, which means we will actually delete all unneeded Parquet files. They are not existing anymore. But still, the tag was created, which will allow us actually to go back on Apache Iceberg to keep the situation. So the rollback is quite simple done. So now we have that two mechanism inside of Iceberg native. So I know, like previously, you probably heard about Project Nessie, a catalog that created the branching tagging as well on a catalog level, but Iceberg introduced that on a table level, which gives you like a similar way to play with data. Good. That is a theory. So let's just go and try to kind of build a demo and see how everything works. Oops. So let me just log into. So what I'm using here is catalog Lakekeeper, and let me just drop the whole branch here. The namespace, because we don't need that at all. So what you see, maybe just to give you like kind of an overview, we have a warehouse based on AWS. And in that warehouse, we have on a single namespace. Now what we're going to do is to create, first of all, a client. So we're using here Spark. And the first step is going to be to create a namespace and load some data in a table salary. So okay, looks good. So we have Alice and Bob. So let's just go here to Lakekeeper back. Now we have a namespace branching test. Going on the table, we have a salary. And if I go to the preview, I will hopefully see Alice and Bob, and we see exactly the salary of Alice and Bob is same 60K. All is good. And now if I will go to a versioning, I see exactly the snapshots, because every change in Iceberg is a snapshot. That's exactly what I presented on my deck, on PowerPoint deck. Which means every time when I do some change on Apache Iceberg, I will create a snapshot. Let's just go and load a little bit more data. Right now I have 2 inserts, which means I will create how many snapshots? 2, yes. We will create 2 snapshots. Let's see if we got 2 snapshots exactly. So now I have 2 snapshots, and if I will go to the preview, we will see more data. So we see Bob, Alice, Max, and David. And by the way, if you use the snapshot, that gives you exactly the time travel capability what you have on Iceberg. So you can just easily go, let's say, what was like the first slot, the Alice and Bob, and then we've got actually Max, and then the last slot was with David. So that's exactly what the time travel capability on Iceberg is. And on a versioning, I can exactly see the whole history, and I can actually go and compare like 2 different snapshots if I want to dive in kind of like understanding what happened here on all of this. But let's see what we want to start with. So now we created this data. And first of all, what I want to create is a tag because I'm just about to make some changes to my table. And I will create a branch. So let's refresh and see what we've got. So right now we've got a main branch, the audit branch, and we've got a tag recovery point. And the next exercise or next task is on our end to make some changes on the table. And you see that we're inserting like a new data, we're making some updates, but everything is done on a branch, audit branch. So if we'll execute it, let's just refresh. You see right now we've got some changes on our audit branch. So if I will go back to the preview, and let's assume I'm just a simple user who is on the main branch, I still don't see any changes. But in our case, an HR manager needs now to go and look at the data and make some audits, and they see all the changes. And the changes is like we added a new user N, and Bob had now the salary change. Now Bob increased the salary to 70K. And it looks kind of okay. And what the next operation would be in that write audit publish approach is actually to merge the data. So everyone who is on the main branch is able to see the data as well. And for that purposes, I will just go and say, okay, merge to main. And in that case, going back to the preview and just run a simple select here on the main branch, I'm able to see the whole data. So what we actually created now, like a simple insert, and you can imagine on that audit, you can do like all different checks. You can do like a quality check, you can do a business check, and so on and so forth. So now exactly is the point where we will say like the lot itself is done, and I'm just ready to delete the audit branch because I don't need that anymore. And what the next step would be is just to clean up the table. So we will run the expire snapshots here, which means all the snapshots before the last one will be deleted physically. So the Parquet file is just gone in that situation. Let's refresh. And this is how it looks like right now. So now we have our last snapshot, and we have like the information about the snapshot that was tagged. So it's not deleted yet. And let's assume the situation that we done our change on Friday, everyone was happy. And on Monday, we've got like our manager back and who is saying like, oh, we made some mistakes. Actually, we need somehow to roll back. And in a classical way, you need just to go and kind of like trying to do what? To restore the deleted Parquet files, call someone from S3 storage, maybe ask them like, oh, do we have a soft deletion, and so on and so forth. What we want to do is like, because we're not sure that data is really corrupted or not corrupted, but we will just put here a tag as well, just in case. Keep it. And now I'm just going to a previous state, and then we'll just roll back. And going to the preview, I'm exactly at the initial state of my table before we started to do anything. So we have only those 4 inserts, which means we don't have like a change over Bob from 60 to 70. So Bob gets still the 60K, and we don't have like an additional user N here. And going back to the versioning, we see exactly the situation that we activated our version 3, in that case on Apache Iceberg, without making any changes reloading. And you can imagine, I don't know if you have that experience, if you would just go and try to restore the whole table, it will take you probably longer than the couple of seconds what I was here using for this. And if you will say like, well, it was actually all good on that version, we can just go and roll back. Well, roll back is probably not the right. roll forward to the version and going to the preview, now we will just restore the state as intended as we got the whole changes here. So that's kind of like the way what Apache Iceberg is able to provide to you in a simple mechanism without be very panicking if you made any mistake, which means you can play with your data as you play with your code, which was not really possible before that. If you have like your table and you do any changes, everyone will see that change and that can impact your productive system, right? And compared here to Apache Iceberg, it's quite interesting what you can achieve. So the key takeaways from a write, audit, publish, and restore is that you can use branching on the tables and use it. It's native mechanism inside of Iceberg, super easy to use it either with Spark, with Catalog, with UI, with API, whatever you want. It's usually the metadata only operation, which means you don't need to plan a lot about like, okay, how are we gonna copy the data in case we will break the data will become corrupted. Tags is very useful in case you want to run some backups on your data. And that will protect you on whatever operation you want to do. And especially like with tags and branch is quite interesting if you're on artificial intelligence, on AI, and you want to run some ML processes, you can create the data on your branch, you can run your ML trainings, and you're not disrupted by any productive process who is changing your data all the time. That's quite interesting here. And instant rollback. Oops. So that means you can just go and then be very well self-efficient in that situation. You don't need to call to your colleague on a DBA and ask for a favor. In that situation, it's quite simple for you just to keep a control. That was the topic what I wanted actually to present to you. Again, a boring one. How to survive your day, especially it's a Friday afternoon and you do some changes. And guys, if you like it, give us a star. We are a young startup building a Lakekeeper catalog. That's it. Thank you very much. If there is a question, I'm happy to take that. There are no questions. Oh, there is a question. Go ahead. For what? There is an API. It's Apache Iceberg REST API. You can use it. I was looking it down from like a Claude Code style. I think Claude can do pretty much API as well. Yeah, absolutely. So, I mean, there's an open API specification. Just give it to Claude, and Claude is very fine to use it. Perfect. Then I would say, oh, one more. Can main branch evolve when I have another one? Evolve in terms of adding data or changing schema? Adding data. Yes, you can add data, but you cannot change schema. That's kind of a limitation. You have a conflict. Yes, you need to resolve it yourself today. You have Spark. It's a powerful Swiss Army knife. No, that's the reality at the moment. So inside of the standard Iceberg REST, there is some conflict resolution, but that's not that mature as you will probably have. So if you will do some changes maybe on a partition that not conflicting with something else, it would be possible. But if it's conflicting with some data, which is like ahead of you, you're not able to merge that branch. Inside of Iceberg, you mean? Yes. Yeah, so it depends on the version. There's V3, which... What happened? Was not intended. So in Iceberg itself, you have a mechanism that tracks the roles. But the main thing is about like, okay, you have like different snapshots. You need to click here something, I guess. Yeah, and that is like a built-in mechanism on role lineage inside of V3. All right, there. Go ahead.
Is my assumption correct? The branching back under the hood is more like logical abstraction, and under the hood they mostly snapshot ID, or is absolutely different under the hood from snapshotting?
Well, yeah, so it's a reference. If you look, let me just show you that. Probably we can see that directly here. So if you go to a ref, here we go. You see exactly that we have a reference block, and that points to a snapshot ID. And that helps you actually to stay with your branch to the specific, oh, yes.
You can explain.
Yeah. It's going to take like a second. But if you look at the metadata JSON file of Apache Iceberg, you will see exactly the block of reference. And that block of reference point to a specific snapshot ID. And then, yeah, exactly. Here you can actually see. And then if we look for, I don't have a branch. Let's just go here. Create branch snap ID ref. You can see exactly here, I have my branch and I have a reference and I have a snapshot ID. And that is actually what helps me. And then I'm adding something on that branch, I will have like the history for that specific branch. And that is like why we can see here this type of a Git-like experience with branching without making changes on the data itself. Okay, thank you guys for your attention. And now we will go to the next speaker, Vinny.
Sick. All right. Victor, your beer. Cool. So after a bunch of technical difficulties, I'm ready to start. I'm Vinny. I'm an engineering manager at Staffbase. And my talk probably is the least technical one of the night. Instead of looking at what Iceberg can and can't do, I'm going to be asking the question of what happens after you start with Iceberg, after you have it established in your org. What's kind of the next steps that you should take? Now, the side note for anyone who doesn't know me is before I worked in data, I used to work in a cafe. And it was a lot of fun, especially because at some point the service ends and you get to go home and clean up, and the next day you do it all over again. At data, when you're working in tech or in data or anything related to that, that doesn't happen. So it's up to you to figure out where you're going to stop. And that's kind of the point that we got ourselves in at Staffbase. We have a foundation that works, pipelines are running, the team is shipping, but then we need to figure out, okay, what comes next? Where do we kind of stop? What's our target? What's our goal? It's not just like have someone come into the door and get them fed. That would be very easy. So we basically have to decide that ourselves. And what I'm going to walk you through is the making process, how we've sequenced those things, and where we are now to some extent. Taking some liberties here because a little bit of this is still in development. So getting there, what we realized is that the answer really for what people need, what a mature data platform looks like, doesn't really have anything to do with the stack. Like nobody cares if you're running Spark or Flink or Kafka or Nuts or whatever, right? Like those technologies are not super compatible, but like just bear with me for a second. It really has to do with, kind of we came down with like 4 things. And it really comes down to trust, the visibility, consistency, and accessibility. So basically, on a very, very high level, people need to trust the data. We, at least as a data platform team, need to know what's happening in the background and need to be ready to react if something is going wrong. The metrics that we define, whatever we expose to our end users, be it internal, external, customers, whatever, they need to mean the same thing everywhere, and people should ideally not be having arguments about what a new post means or what reach means or whatever. And finally, the data access shouldn't really require a ticket. And by ticket, I mean not that you're like requesting for permission. I mean really just like putting out a ticket for your analytics team that will then somehow, some point, answer the question when they find time for it. It really should be a matter of kind of like, being able to self-serve. So this is kind of the 4 outcomes that we've defined, but that's still not really, you're still not talking like a data platform language. We set a destination, but we didn't really have a plan of how to get there. And after kind of going through this exercise, what we found are basically 3 separate bets, essentially 3 kind of overarching themes that we'd be looking into. And this again, to go back to the service industry metaphor, it's no different than building a kitchen or a restaurant. You have to have the right equipment, have people in the right stations, have the right order of process of steps happening before anything hits the customer. So the first thing that we looked into is essentially just observability. And to make a very long, summarize observability as much as I can, which is, it could be just a whole talk by itself, just looking at timeliness at the moment, which is arguably the simplest one to define. When you're working in a batch type of environment, timeliness is very binary. Either the pipeline ran before the board meeting happened or it didn't. Ideally it did. But you can have an answer, it passed or it failed. When you're running into more of a streaming, you need to know how far things are going from normal and why, ideally, right? So instead of looking at just a binary like, okay, this did this run in time or did it fail? Usually this drift happens more on a, what's what I'm looking for, a kind of direction. What we did here, this is the only technical part of the talk, really, is we're really just, in a very, very simple manner, and again, this is not how you should build it, this is just a way that got us running very quickly, was to basically just compare the time that an event happened to the time that the Iceberg snapshot was created, essentially. It's a very simple one. And the snapshot, of course, being like in the final layer. So if it's within our defined SLA, let's say 5 minutes, 3 minutes, whatever, then we're good. If it's not, then we need to figure out what's happening, what's delaying it. At a second, and I guess arguably the more interesting part, is looking into semantic layer. Again, this goes into making sure that things mean the same no matter who's looking at it, right? Can the business trust? Can the business actually use what we're doing? And in our case, we have basically 2 customer modes. They can, I think it's actually not going to be that uncommon, especially at this day and age, that you either have a dashboard that's very static, that's kind of simple in a way, even though there's enough challenges with that one, but it becomes a lot more complicated once you add AI agents to the mix, because they're also going to be wanting to query the data by themselves. And if a question is asked and there isn't really a clear definition for how to answer the question, chances are the agent's going to start looking for answers by itself. It's going to start coming up with something to make sure that that question is answered. And this is where the semantic layer comes in. Because anything that goes through the agent, your user, your customer, whatever, it's going to see. So you better make sure that it's well defined and that whatever the agent touches, it can actually parse, it can actually understand that, this is how we define best. Things that are very kind of arbitrary even for humans, they need to be documented somewhere. A way to think about it is just, thinking about it as if it was a restaurant menu, and that you want to give your customers something that they can order from, something that's prepared that you can deliver on, and not let them guess, not let them go into the kitchen and figure out like, oh, give me some potatoes and some steak, and I think that's going to be a good meal. No, like you're the experts. You're building out this menu, building out the spices. So this solves basically how can I put it? This solves just making sure that the customers are seeing the same things. But if something breaks, you need to know who to blame. Shouldn't say that, but without doing any finger pointing, of course. But you need to have an owner. So the observability and semantic layer, they solve a lot of our issues, but the problem is producers are still acting independently for the most part. And this is where this is where you need to implement something like a data contract, so that your producers and either you as a data platform team or your consumers are agreeing on what you expect them to deliver. Iceberg has this really nice schema evolution feature. The problem with schema evolution is that it's just kind of a slower way to break things if you don't know that a change is going to be coming. Ideally, you want to know that your supplier is going to change their delivery before they actually do. So you can adjust your menu, so you can adjust all the steps that are going into preparing the dish, if you will. So what we did with data contracts specifically is, I think, first off, the first step that we took was actually to try just big bang it out. And of course, it didn't work because there was no trust built. And what we realized is that it works a lot better if you just start small. If you implement contracts on those key points that customers or that your producers really need that data to match, and that your customers also really need that data to match. So you start small, you just grab a couple of fields, a couple of tables, a couple of processes that are feeding the data. And once especially the producers see that there is a value in having the contracts in place, and the org trust is built, then you can start expanding. Then they're going to be a lot more receptive for whatever comes afterwards. I'm going to be a lot more receptive if you say, hey, you have this huge table, and I would like to set up a contract for this whole table because it's actually important for us. But you need to actually, you need to gain that trust. It's more of a, it's a human problem at the end of the day. The three things that I mentioned now, there's nothing new under the sun, of course. Like if you ask 10 people that work with data platforms, chances are that 8, maybe 9 of them would answer with very similar things for what a mature platform looks like. It's been around forever. I don't think there's any argument. Like you could arguably add more things. You could, maybe add more, but I don't think anyone disagrees that those things are important. The thing that we are looking at is really that they just kind of wind up reinforcing each other a little bit more. We need observability, even though it gets deprioritized. It's very easy to deprioritize observability because things can be running and you just don't have to care about it. But if they break, you want to know. But ideally they don't break, so you just don't worry about it. But you need to have it in place if you want people to actually be able to trust things. If you want to be able to sign your name off as it is on that your customers are actually getting the things that they want to see. The semantic layer, having a semantic layer without trustworthy data underneath, really is just kind of infrastructure that looks confident, but really isn't. It's going to look all right. The measures are going to be super well defined, but then at some point, someone's going to realize that it hasn't been updated in a day or two or an hour, however long your SLAs are. And that's where trust breaks. So you need to ensure that that trust is there in the first place before moving forward. And the contracts comes last because it's easier to set up contracts once you know what you need to protect. If you try to just big bang them, as we did initially, you'll find that no one's going to buy into that. Those things, they look very clear in hindsight. It's very easy for me to come up here and say, hey, we've done it. It's good. But the truth is that backlogs usually aren't clean. It's very easy for me to literally write here on my speaker notes that I need to instrument first, stabilize the interface second, and formalize the agreements third. It sounds very clean. It sounds very punchy. But looking back, it was very messy. The important thing that we've done is really to set what the destination looks like. And then just ask ourselves if what we're taking in actually moves us towards that or not. And that becomes very important once you have 5 different teams banging on your door saying like, hey, I need this thing from the platform and I need to be able to run my workflows in 5 minutes instead of 7, and I need you to enable this. It's easier to deprioritize these things. It's easier to say no to these things once you can tell them, look, this is our goal. And if this is really important to you, then take it up with my boss or whatever. This is not really a methodology. This is just a way of kind of making decisions that felt easier and that don't lead me to question my life choices and service industry or something. I think the thing to wrap up with is that tech just is easy. It's honestly, like, I know I'm hearing some people laughing, but tech really is easy. It's people that are the problem. Tech is binary. You can tell if something works or it doesn't. I'm sure I'm gonna get some questions or comments on this. And Iceberg really solved storage for us, but what comes next really becomes an organizational issue that you just have to think wider more about. You need to figure out who owns the data, how to use this data, and who's accountable for it. Those are people problems, they're not technology problems. I still haven't found a technology that can fix it, and if someone knows, then I will pay a lot of money for it. Hopefully, take it up with my boss again. So yeah, if you take just one thing, talk, just the destination and people just matter a lot more than whatever stack you choose. Let those lead your decisions, and it's probably going to be a better bet. That's at least what I've learned. I'm done. Thank you.
Any questions, guys? To really about how much you will pay.
Take it up with my boss again.
Any questions, really? Go ahead.
So I find last part, so the tech is easy, fast, which is definitely the case. Technology shapes people. What about using something like data mesh? Because it was originally designed for the same vision where every silo has their own definition of terms, and then you just have it copy and paste.
Okay, I am not sure how the room is going to react to this, but my personal opinion is that data mesh really is only usable in a very small subset of companies that have a very strong engineering and data foundation, essentially. It's not the case for, like, speaking specifically about Staffbase, which is a company that I work at. We are about 800 people, 200 engineers or something. Our data team is 5 people. We can't have a data mesh there, right? Well, what we can have is just have I personally am a bigger fan, especially for our stage, of like a hub and spoke kind of model, where we just have like centralized definitions and centralized architecture, but we can still have spokes that are kind of self-serving, both as producers and consumers, depending on what they need to do.
And so my experience with the centralized depot for contracts is the number of PRs just grew over like 6 months, 7 months. Have you seen that happen?
Yeah, I'm gonna say that we haven't had this running for long enough that I could tell you if it actually is gonna grow as much over time. But I can say that the target, like if I'm just looking to have the contracts much closer to where the data is actually produced, instead of just having like a centralized thing. Just to make it easier on the, but this comes down again to more last couple of you have those changes, which is why it's, you know, pair the necessary, but you know, trying to keep it as low as or not. I've heard of companies that have data contracts that need to be announced about 3 months before they're actually changed. That's actually a story from one of my team members in her previous company. That's not something that we've ever wanted to get to, right? So we still want to be flexible. We just want to be able to react to changes before they actually happen. Yeah, Jesus.
Good. Any other questions? Seems to be not the case. Denny, thank you very much.
Oh, thank you.
Share my screen. Do that. Hello?
Screen share.
Screen share. Sorry, we gotta deal with corporate permissions, everybody.
You're not sharing it at the moment. It's okay.
Yeah, it's fine. Don't worry, Snowflake. You're gonna be totally okay. Okay. You still working? Do I need to reload your Jupyter Notebook? Okay, you're Gucci. Okay, window. Yeah, I do. Actually, no, I want to show the entire screen. We're gonna do that. Okay, and we're gonna do that, and I'm gonna quit Slack. Okay.
It's just black to share it here as well. Thursday.
Ah, okay.
Now you need to.
Drum roll. Oh, entire screen? Yeah, okay.
I guess you all set.
Okay. Think we're good to go.
Yes.
Okay, everybody. Sorry about this like random light bar that won't go away. You're just gonna have to deal with the frame, I guess. Hi, we're gonna talk about a Postgres extension called PG Lake today. My name is Celeste Horgan. I work for Snowflake Computing. And you may be wondering, I thought I was in an Apache Iceberg meetup. What are you doing here? This is Inception. I don't like it. And that is all very, very fair. We're going to talk about why all of this is happening to you. And at the end, you can potentially get a sticker for your troubles. Okay, here is a slide that I'm sure you're going to read that Snowflake says that I have to put up. Look at the slide. Next, let's talk about the agenda. So we're going through the intro section right now, if you can't tell. We're going to talk a little bit about Postgres in the year 2026, because again, you're probably wondering, why am I here? This isn't what I signed up for. We're going to talk about PG Lake, which is a lakehouse extension for Postgres. We're going to do a little bit of a demo, like drum roll, let's hope it goes well. We're going to talk about some sort of additional tools and other extensions you might use alongside PG Lake to do lakehouse shaped things. And then we're going to do a bit of a conclusion. Does that sound good to everybody? Not that you can change the slides or the order of the slides, but I thought I'd double check. So like I said, my name is Celeste. I'm a developer advocate at Snowflake on the open source team. I also sit on the Postgres EU DEI committee, and I do code of conduct at conferences there. And I also run Snowflake's open source programs office. So why are we talking about Postgres in 2026? Because not only is it still the most popular database out there, it's actually growing in popularity. So this is the most recent snapshot from the Stack Overflow developer survey, where it shows Postgres at the top at about 58.2%. The last time I made slides showing this particular screenshot from the Stack Overflow developer survey, I believe it was actually at 42%. So not only is it the most popular database out there, it is the most popular and growing. And you might be asking yourself, why? Because isn't Postgres like super duper ancient and you only use it for basic things? That's a great question. It is in fact ancient. It was open source in 1995 after being in development at Berkeley for quite a while. It is one of the kind of OG open source projects. That's why it has its own open source license. It doesn't use Apache 2 or MIT. It's why it has its own sort of nonprofit bodies surrounding it. There's been about 200,000 contributors to the project over that 30-odd-year time span. There's 18 versions with additional minor versions and bug fixes attached. And it's deployed in basically every single country in the world. And the documentation is available in 30 languages. So why is it still relevant today, I think is the more interesting question. And I think the short answer is it's incredibly robust extensions ecosystem. Postgres core in and of itself is very unopinionated as a database. You can kind of just do table-shaped things. It has always adhered very, very closely to the SQL standard and is in many ways the de facto implementation of the SQL standard. And because of that, it is very, very easy to extend to do a lot of customized things. And that's why it's always cropping up. If you want to do geospatial data, you have PostGIS. If you want to do columnar data, there's a whole bunch of extensions that you can do, et cetera, et cetera, et cetera. And that's why we care about this lovely thing called PG Lake. So as some of you in the room might have known, about a year ago, Snowflake acquired Crunchy Data, which was a very, very popular and very well-loved Postgres startup in the ecosystem. If you think this is cute, I have stickers of this. Just FYI, talk to me at the break. So what does PG Lake do? As you might be able to tell from our adorable sticker with our adorable elephant, it provides Apache Iceberg functionality within Postgres natively. So what it lets you do is read in Parquet files from S3 storage as an Iceberg table. So it'll compose an Iceberg table for you. It will also then copy that Iceberg table back into S3 storage, so you can do Iceberg shaped things in Postgres, and there's a whole bunch of reasons why that might be useful. So like I said, it's a set of open source extensions that lets you kind of import and export raw data files into a Postgres shaped table. And because Postgres is so common and so easy to work with, that is really like the sky is the limit for things that you may or may not want to do. Digging a little deeper. This is not the slide that I want. We're going to pretend this didn't happen. There we go. So digging a little deeper, the way that this actually works is basically you as a user are only interacting with Postgres, and you're interacting using standard SQL asterisks. It can't all be standard SQL because we are going to do some extra like Iceberg specific stuff. You don't necessarily have to use Iceberg. You can kind of just read directly to like object storage if that's what you want to do, but like most people tend to want to do Iceberg stuff with it. How this works under the hood is it actually uses PGDuck Server, which is an implementation of DuckDB to do the heavy analytical processing. The reason for this is that Postgres natively is not great at analytical tasks. In fact, one might say it is not the preferred choice for analytical tasks ever. But DuckDB, which is itself a Postgres extension, is quite good at them. So we delegate down there. And the reason that we sort of care about being able to process analytical workloads in that way is, of course, because why else are you storing things in Parquet files? Like this is sensor data, it's IoT data, it's like random clicks on a website data, it's observability data. You care a lot about the storage for that and a lot about keeping that compact, but occasionally you do need to read it in and do some fun stuff with it. So you kind of get the best of both worlds. You get like a nice, easy sort of Postgres-y interface to interact with, but you also kind of get something a little bit more reliable and robust to actually do the retrieval. So it kind of just does Postgres stuff super easily. It uses the same DDL to talk to your data like as you would for any other Postgres thing, which is also super handy because it's just one less tool that you have to kind of manage and think about for your developers. As mentioned before, it does Iceberg-shaped things. I don't think that I need to go into too much detail about the chart that everybody talks about when they do the Iceberg talk. You've seen the chart before. We're cool. The thing that I would note is the thing that's in bold is acts as both a query engine and a catalog, and that is, again, quite useful to you. Demo time? Demo time? Okay. So we're going to do a little demo. We're going to build some tables using Iceberg, and I'll show you effectively what that looks like. We're going to read some data in. We're going to copy some data to Iceberg. We're going to query it back out, and we're going to do some fun little joins. Okay, wish me luck. This is always scary. What do I want to do? Okay. So all of this, by the way, exists in a repository. I am absolutely going to go back and forth through my notes. Do not come for me. And apologies, I want to go here. If you did want to follow along, my GitHub username, this is very small, is Celeste Horgan. It's called PG Lake Meetup in a Box. We'll probably open source this under Snowflake Labs like pretty soon. It just takes a minute. So let's just take a peek at the sort of Docker file so you understand what is going to be spinned up, because a few different things are going to happen at once. So first off, we're going to do this thing called the PGDuck server. This is going to give us DuckDB so we can actually run these sort of analytical queries against an S3 bucket. So that's sort of thing number one. Thing number two is we're pulling in local stack. And this might get sketchy because when I tried this earlier today, I did have to pin this version and it's not showing up on my main branch. So wish me luck, everybody. Local stack lets us deploy an S3 bucket locally. This is just so that I don't have to connect to an S3 bucket like live for you. So that's thing number two. And I believe somewhere there is a PG Lake server that I have missed. There we go. So that's the other thing we're going to deploy is a PG Lake server. Nothing dramatic here. You just can't see it. We're going to do a little Docker compose up. No, it's totally fine. Don't worry. Yeah, we're good. Okay, and this is where I'm going to do a little bit of copy and paste, and do excuse me, I'm just like not going to mess around. So first things first, we are in fact just dealing with the normal Postgres. That didn't work the way that I wanted it to. Love that for me. Oh, that's because I didn't connect to Postgres. Excuse me. Yeah, there we go. Okay, so now that we've connected to Postgres and we aren't totally stupid, is everybody okay with the font size? Bigger? Bigger? Like a little bit. Let's go a little bit bigger. Okay. So this is more or less just normal Postgres. As you can see, there's like nothing super crazy going on here. But we also have no data. So let's drop in some data. There's nothing super exciting going on here. We just need something to query. We're using IoT sensor data, and this, as you can see, is not particularly exciting. What is going to be exciting is when we create an Iceberg table. So you'll notice that this is just a normal Postgres create table command, and all we're doing differently is we're saying using Iceberg. If you want, you can actually set PG Lake to default to using Iceberg tables, so you don't have to declare this every single time you do something. For our purposes, we're going to do it. So we're going to create a table called sensors. We're going to create a table called readings. As you can tell, we're going to be looking at some sensors and some readings. Again, nothing super exciting happening just yet. Same here. We kind of just need some data to play around with. So we're just going to insert some kind of dummy data. Okay. I am zipping through this way faster than I thought, so maybe we'll catch up on time. Okay, so next, let's do a little bit of a join. What we're effectively going for here is we're joining the sort of name and city to some of the sensor data that we have, and we're doing a bit of a group. And again, you'll notice that this is not like anything special. If you've ever looked at SQL and if you've ever worked with Postgres before, this is a perfectly normal join. And that's kind of the beauty of this, is you don't need to learn anything new. So especially I think if you're using kind of Postgres as the main driver in your sort of data space, which a lot of people are for a lot of reasons, because Postgres is the most popular database and it's all over the place all the time. This is a very, ooh, rude. Oh, I see. Okay. Okay, there we go. That was a copy and paste error. It's super duper handy because you can simply just create and use Postgres tables, and you don't really have to think about managing an Iceberg table. Now, I will say this, if you want to get into sort of like snapshotting Iceberg tables, you're going to want to default back to like interacting with the table directly via the S3 bucket. PG Lake won't actually do that for you, so FYI. Okay, that said, let's take a little peek at our metadata for our Iceberg table. And you'll notice that it is deploying things as JSON files to our sort of local S3 bucket. So it's behaving exactly how you would expect an Iceberg table to. It's generating metadata every time we sort of make a change. Let's do a schema evolution really, really quickly. We're, again, going to just alter the table. We're going to do some inserts. We're going to do some selects. And we're going to see sort of what happens at the end of that. And apologies for the copy and paste here, but that's kind of the energy we're going with. And if we then sort of move through and sort of copy the table, we can export it to Parquet. Now, here's where this gets interesting, because we've been playing around in Postgres for a minute. But fundamentally, the reason that we like using Iceberg is because we're trying to standardize across a number of disparate data sources, right? And we're trying to sort of have a consistent data layer that we don't necessarily need to know what's behind. The lovely part about all of this is that last step that we did just exports this all as an Iceberg table. So when we're ready to sort of have it interact with things in an Iceberg first manner, that part is sort of taken care of for us. So before we do anything, we're going to get our kind of metadata location, and I'm going to copy this over as a little proof of concept. And again, this Jupyter notebook is in the repository if you are interested in doing that. So there we go. I'm going to hit run. Basically, what we're going to check for here is that we're getting the same data here as we pulled out over here, because these are the same table and they're pointing to the same direction. And we don't necessarily need to interact with this Postgres first. If that's not what we want to do, we can access it via another source. So this is actually running directly from DuckDB. You don't have to use DuckDB, don't worry about it. But you will notice we are in fact looking at the same data. Not that I can find it for you because that would be embarrassing and that would be too easy while doing in front of a live audience. But yeah, it's the same data, and I think that's actually what's really, really interesting about this. Ta-da. So, concluding. You're probably not going to use PG Lake in isolation if you do decide to deploy it into production. Typically, you're going to want to use PG incremental to sort of sync and append data from Postgres to external sources, because you do need to make sure that anything you're adding directly to Postgres is then reflected in your S3 bucket. You're probably going to use PG cron to set that up. And you're probably also going to use PG Partman, because PG Partman specifically will help you manage time series-based data. Cortex Code CLI is like shameless product placement. But if you did want to interact with this using an LLM, and if you are a Snowflake customer, it is a pretty great way of doing things, and it's a pretty intelligent coding agent. That said, I think the thing to understand is if you are kind of using Iceberg from a Postgres first perspective, if you will, there is definitely a risk, I think, that things that get inserted into a Postgres database then aren't reflected in the Parquet files or vice versa. Those things can get out of sync. I think that the other risk that you really need to sort of like manage and keep in mind is how you're handling metadata versioning. Or else you're going to get into some real issues. An Iceberg table is still an Iceberg table in the end. But there are lots of reasons why you might want to be able to sync up a Postgres table with sort of what's represented in an Iceberg table. One is having a bit of a sync between a transactional database and an analytical database. And quite frankly, most companies have both deployed at any given time. A part of the reason why Postgres kind of keeps cropping up is sometimes you just need a database. But if, like our last speaker, you're kind of trying to create a more unified data platform or a unified data access, at some point you need to start thinking about like, how do I get these things to reconcile? And Iceberg is a really, really useful way to do that. And if you can get Postgres to talk to Iceberg, you're in the money. The other thing that I would really highlight about PG Lake in specific is that it is open source. Snowflake has zero plans to close source it. We are in fact trying to do the exact opposite. We're trying to grow the community and make that a little bit more diverse because we really believe in the technology. But also it was developed by Crunchy Data, and it was developed as an enterprise grade piece of software. So it is in fact robust enough to support your needs. That said, again, there's all sorts of reasons why you might want to sync Postgres up with something going on in cold data storage. And I think the most obvious example, at least for me, is a hot cold tiering situation, which is like really, really, really important these days, especially because most people are generating so much data. The other thing that always comes to mind is like any kind of analytic workload where you're trying to generate, say, like a chart or a graph, or like you're trying to render out a subset of data that has lived in cold storage. You need to load it hot first. Schema evolution is another really obvious example, and I think any kind of data archival, to me, those are the most obvious examples of why you would deploy this in production. If you are curious, you can find the source code available at Snowflake Labs/PGLake. Like I said, it's an open source repository. It will remain that way, at least so long as I am there. As previously discussed, PGLake isn't just one extension. It is one extension that kind of coordinates 2 or 3 other extensions, the most important of which is Duck Server. There is a Docker deployment in the repository. That is definitely the easiest way to get started. And you typically, again, you're always pairing this with an S3 bucket of some sort. That's all she wrote.
We need only Postgres, right? So nothing else.
Listen, look at the back of the laptop. This is a Postgres house. I mean, I have a lot of love for Postgres just because I think it's an easy way to, whenever somebody asks me, how do I understand data? I always tell people to learn Postgres first, because then you can understand how things are different or similar to Postgres. I think it's like the most beginner friendly platform, and I think it's the most like flexible platform, but it's not right for every use case, but it's right for a lot for a decent chunk of time. So I think it's always important to, like, when you're thinking about sort of building out like data pipelines and building out data platforms, it's like you have to sort of think like at some point somebody's going to throw Postgres in there, and like, what am I going to do about it? You know?
Any questions, guys, about Postgres?
Does PGLake support time travel?
No, you're going to want to interact with like the actual Iceberg table. So basically what you would do is like create your Iceberg table using Postgres, if that's what you want to do using PGLake, upload that metadata to S3 storage, which again, PGLake will help you do. And then I would interact with the Iceberg table using like Iceberg's command line tooling and REST interface. I think there was a question over there than you.
So 2 years back, I had an experience working with DuckDB with Postgres, and we tried to build something for our tools. Since DuckDB dynamics are closer to the Postgres as mentioned. We found some issues with, at the time, DuckDB wasn't complete, but some of the syntaxes are not translated well, and some of the syntaxes were, I think, still might have issues if we would like to use some functions. And we find one constraint about that the DuckDB doesn't perform well in concurrency system. Like
Okay.
Has it still like once you approach DuckDB service server, only one service will run. So if you have multiple services trying to write into the database file, does it still work?
Off the top of my head, I don't know the answer to that. I'm trying to think about like, sorry, let me download the implementation here. I don't know the answer off the top of my head. If I had to guess though, I would say that they're handling concurrency using Postgres, because Postgres is much kinder on the concurrency front than DuckDB is. That's a guess though, don't quote me on that. This is being recorded, so I am shooting myself in the foot, but okay, hi. Good question. I believe the transaction boundary is defined by the Postgres, right? So you're defining it on the Postgres side of things, and you're closing out the transaction there. And then it's going write ahead log, then it's going to DuckDB to actually do the read, write, or copy. Yeah.
What is the type parity between Iceberg and Postgres?
What was the, excuse me?
Type parity, type system parity.
Oh, that's a very complicated question. It is, however, I believe in the documentation for Postgres, because I was looking into this because I was afraid that somebody would ask me something complicated. There's a list of supported types in the repository. And it's more on the Iceberg side of things that's getting defined than it is on the Postgres side of things, is what I got when I skimmed through it just before to make sure that everything was like fresh.
More questions.
One more question. Hello.
So tables. Does planning still happen like on Postgres?
Ooh, that's a great question. Sorry, I'm just gonna come up to you and ask. Okay, sorry, again?
So when you join tables
Yeah.
from Iceberg and Postgres, does that happen planning of query ordering, join ordering happen on Postgres? Or does
Okay.
it utilize Iceberg metadata?
Great question. Okay, so the question for the recording, but also for me, was when you join tables, does it use Postgres's plan functions? And how does that affect the Iceberg metadata? I believe that the implementation is actually to use the Iceberg metadata. I don't know about the planning off the top of my head. Yeah. I mean, don't ask me my questions, Rory. Okay, I think we're gonna call it. Yeah.
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 Thank
Okay.
you very much.
Thank you.
All right, guys. Now we have 20 minutes, 25 minutes. Walking, grab a drink, and I don't know, like if we have still some food. I guess no. Yeah. So it should be some food. So 25 minutes networking. See you soon. Don't run away.
Oh, 'cause I didn't even Oh, no.
So let's start with the next talk. Take a seat.
I know. I just, so my research is a technical writer, I think so I didn't get quite nervous when I'm doing like. I'm a developer admin.
Okay. Can you hear me, guys? Nice. Hello, my name is Andrei. I will today present something slightly more open source and less about business. I will pitch you guys idea that Java is not that good for data analytics. Maybe someone will start looking on the something new in their life and choose a better language to the goods. I will talk about Iceberg Go. So my name is Andrei, as I already said. I'm Apache Iceberg maintainer of Iceberg Go library. It's not that popular, honestly, but it is. It's a good library, and I will prove you that it's a good library today. Also, as a side hustle, I work as an engineering manager at Databricks. Okay, so agenda for today, I will talk about a bit of Java, that Java is bad. Then I will talk a little bit about Go, which is that Go is good. Then I will show how you can use Iceberg with Go and what Iceberg Go is capable for, and we'll promote you some ideas about contributing to Iceberg Go. Yeah, so a Java addiction. Java addiction is a bad thing. Java is a big community, a big class passes, big stack traces, big everything. So if you look on about how this works in real world, Iceberg has some sort of Java addiction, and every Java usage, every Java application has this addiction. Iceberg in most notable example. For example, if you try to use Iceberg Python, deeply inside of the Iceberg, there would be a JVM roots. There is actually usage of JVM inside of a Iceberg. It's a bit of a shame, but it is. And even if you want to read a very small table in Iceberg, if you want to just analyze something of this table, you need to bring the whole JVM machine, the whole monster of this thing. You need to install Java on your laptop. It's terrible. So the question here, what if you don't need this? What if you don't need a Java on your machine? I don't have a Java on my machine, and I'm proud of this. And for this, I can use Go. The Go is very nice and powerful tool. It's one binary and zero JVM dependency. Why Iceberg Go? What is Iceberg Go inside of an Iceberg ecosystem? Iceberg ecosystem is a big ecosystem for database. Iceberg, in a nutshell, is just a library for a database. So you can build database on top of that. And there is a multiple connectors. Connectors is an implementation of an Iceberg protocol in different language, because Iceberg itself is just a markdown file which explains how to copy files in it on a file system. That's it. And there is a multiple implementation of this protocol of different languages: Iceberg Java, Iceberg Python, Iceberg Rust, and Go. I didn't mention C++, but it's there. There is also a very important thing inside of a connector library is implementation of Iceberg REST catalog, because not just REST catalog, but catalogs, it's plural. There is a catalogs implementation in Postgres, there is catalog implementation in file system, but also REST catalog, which is most popular nowadays. And Iceberg Go is one of those connector libraries. Recently, it's finally become fully Iceberg v2 compatible. Iceberg evolved in the versions, v1, v2, v3, and very soon v4. And Iceberg Go is finally v2 compatible, which is a very good thing because you can now use it for something production-like. So question here, why Go? Why not a Java? I did already say that Java is bad, but we also have Rust, C++, etc. But the simple reason why I Go, because it's a very good language for stupid people. It's simple, it's universal, it works in the cloud, and it's well adopted already. One thing that which is important, you can just build it and it would work cross platform. It's very fast startup, it's very simple deployment, and very small binaries, which is important if you sit on a 3G internet or something similar. It's very simple concurrency, which is important for data analytics. You have a Go routine model with actor system. You can build a very sophisticated system just with the Go routines. And also it's very well adopted in a broader community. In the cloud, I would say it's a go-to language. Java is already that in the cloud space, but Go is most prominent version. Kubernetes, Docker, Terraform, Prometheus, you name it. A lot of things built on Go. So question here, what can you do with Iceberg Go? And the question, can you read with Iceberg Go? Because the first thing that you want to do with Iceberg table is take a look what's inside of this table. And answer is obvious. Yes, you can do. Here is a code snippet. I will not run it because I'm scared of live demo, but this is a real code snippet from examples. You can create a catalog. You can create a scan as a special object that describe what kind of data you want to read, and you just fetch records. Iceberg Go is heavily bounded to the Arrow, Apache Arrow project, Apache Arrow Go implementation. So you can receive batches of Apache Arrow rows, and then you can iterate through them. It's very simple. And you can just build it and run it. There is some examples in the GitHub repository, so you can build it and see how easy it is. No Java dependency. So in theory, read path is very simple. You connect to catalog. It could be REST catalog. It could be other catalogs. You go to the manifest files. You build this metadata tree from the previous presentation. You saw the chart of metadata tree. You fetch your Parquet files that you actually need to read, and you open for each Parquet file Arrow record batch reader. This record batch reader will read the rows that are applicable to your filter. That's it. That's simple. So the question here, reading is simple, but what about writing? I made an issue a year ago about what about support for writes, and recently it became a thing. About 6 months ago, the append of files was done. About 3 weeks ago, overwrites, replace, and updates were done. So we can have right now a write path for Iceberg Go as well. You can create a transaction, a special object in API. In this transaction, you can append data from Arrow table, and you can commit this transaction. It's a very simple transaction. It's add a file to your table. Simple action. But this simple action is just the first level of a write path. Another thing that is very important for the write path is a Delta API, that you can not just add the data, but also evolve the data, change the record, delete the record, etc. In the V2 spec, there is one set of doing this. It's called equality deletes. Equality deletes store a predicate of what you need to delete, and then we apply these predicates on read. It's a bit clunky design, it's a bit cheaty, but it is what it is. We can do it now. You can create a file with new rows. You can create a delete file with deleted predicates, and on the read path, we will respect them. And those files will also be respected on any other Iceberg reader implementation, because it just simply follows the specification. So for now, we do support two kinds of deletions. There is no deletion vector support. It's only equality deletes and positional deletes. Those two kinds of files are essentially very different in nature. The equality deletes is the thing that store predicates. These predicates evaluate on a read phase, and they relatively compact on a write, but more expensive on a read, and it's force you to have a predicate support on the library. Positional deletes is easier. You just store IDs or row positions of rows that need to be excluded, and the file that applies is position delete. This is a bit more heavy on the write side, but easier on the read side. There is also a third version which is not yet supported, called deletion vector. It's the same thing, same idea as a positional delete, but stored in different format called puffin rowering bitmap. It's a weird way of compacting this information in a very nice and compact way. So this is already done, but Iceberg Go is very, very far from being done. This only V2 spec. There is also very important learning that we will learn during the implementation. Iceberg is a complex project. And in a nutshell, it's just a markdown file. And what could be complex is a markdown file? The main complexity lies in the multi-language nature of an Iceberg. We have a good thing that called Java. I don't like to sense Java for something, but in this case, it's actually helpful. We have a reference implementation in Java, and we always can rely on this, because sometimes specs is not really well defined. There is some corner cases that you have to explore on your own, and you already have an answer for this. So it's a bit easier. But sometimes it's complicated because other languages doesn't treat the Java implementation the same way. And you can have a very weird local bugs and behaviors on different languages about specific implementation that is not fully covered by spec. So this is a complicated story. In the V2 implementation, we learned a lot of small bugs that works on Go, in Rust, in Python, but not works in C++. Or this works in Iceberg version v something and doesn't work in Apache Athena, or some Amazon, or something similar. There is a lot of a compatibility issue that is not yet covered. Another thing which is important, we're starting a big work to pushing Iceberg Go to the V3 compatibility. It's a very funny thing that Iceberg V3 was released, I think, more than a year ago, almost 2 years ago, I think. But there is no fully supported library for V3 spec. V3 spec differ from V2 spec not in a lot of a thing. It's only support deletion vectors in some data types, but those data types are complex. It's a variant data type, which is should also include shredding of variant data types, and it's a complex thing. There is support of a geometry and geography types. It's not that complex, but it's just a heavy work. And also there is a tricky thing about role lineage. This support of a role lineage actually give you a nice things that allow you to implement a CDC read scenario, change data fit read scenarios from an Iceberg with a reasonable cost. Not cheap, but not such expensive. We do have a lot of open work for the V3 support. There is a lot of work in front, but foundation is already there. You can build a sophisticated software on top of the Iceberg Go library, and you can build Iceberg utilities in Go. You don't need Java anymore. Yeah, that's my main thing. I mostly come here to ask you, hey guys, join us. You can take any issue on a GitHub, create a PR. I will review it, and maybe we'll even merge it. Yes, this is a QR code. So you can scan it and give a star for a GitHub repository. It only have 400 and something stars. Please, I expect at least 10 stars for this presentation. And yeah, that's it. That's my contacts. If you want to talk to me, please talk to me. Yes, that's it.
Great. Any questions, Andre? Go ahead.
You mentioned currency model.
Yes.
Simple. I mean, simple as a result of NDS sometimes, right? But how it comes to, I mean, how are you guys using it here, and why is it better than Java?
That's a thing. We don't use it. That's a well. For Iceberg Go is mostly used as a small library for building smaller tools. There is I do know some use cases about Iceberg Go for services that maintain Iceberg the warehouses for doing the vacuum compaction data layout changes. This is much easier to do in Go rather than in Java, and it's easier to deploy. I do know such use case. Also, I do know that there is a couple implementation of CDC ingestions from different system into Iceberg Lake within Go, because we do have a DML support. It's now working more or less fine. They're still complaining that we don't support V3s, but it is what it is. Regards to concurrency model, for concurrency, this was mostly for style workload fine-tuned. So if not overlaps on the partition, it's work fine. Once you have partition overlaps, it's not working. You have just errors. So it's a simple concurrency model.
More questions?
Yes.
Did you see a performance increase through using Go versus a JVM-based language?
Actually, yes. I'm not sure that is because of the library is written really nice, but mostly because Java RO implementation sucks. It's actually more performance than Iceberg Java. If you compare the two tables on Iceberg Java and Iceberg Go, this would be read faster and write faster, mostly because arrow.
Thank you very much, Andrew. And then we have the next speaker, Melvin. So it will take a couple of seconds. I don't know. It's not. No, what? Put it on this.
Worst question on the planet, and you're just like.
Test.
Yeah, just give us.
Oh yeah, let me connect to it. You send it to me in Slack, right?
First, yeah. You're sharing, by the way.
Yeah.
Just go into. Medium low, but disable both.
Both?
Yeah. And no, share screen.
Like this? Okay. Hello, everybody. I'm the last. Okay. So I'm the last one. So this is always a tough position to be between you and the exit. So I'm going to try to keep it brief. So I'm Melvin. I'm the director of product at ClickHouse. So I worked on the core database. Can you raise your hand if you know ClickHouse? Okay, well, that's good. A lot of people know ClickHouse. So for people that don't know ClickHouse, maybe I will just introduce it briefly, right? So ClickHouse is an open source project, right? So we have been around for quite a while, 2016. So 10 years now, like we'll celebrate our 10 years anniversary in June. And we are an analytical database, right? So we are a columnar database, OLAP database. We are designed to be extremely fast. That's kind of one of the main requirements of ClickHouse is really its speed. And we worked on petabytes of data in terms of scale. The good thing about ClickHouse is that it speaks SQL, so people don't have to learn a new language. It's a very efficient storage and a very efficient query engine developed in C++. So that's a high-level introduction. We have tons of customers and users all over the world. If you're using any AI product today, it's probably being powered by ClickHouse behind the scene. We have Anthropics, OpenAI, Cursor, Character AI, Sierra, all of that are using ClickHouse for a variety of use cases, from analytics to observability. We are being used quite heavily. I think if you're looking at the open source project, we are the second largest analytical project on GitHub. The way ClickHouse work is really like, we are a database, right? So we spend a lot of time customizing our own formats. But when you are a database, one of the main things that you need to think about is how do you integrate with the rest of the stack, right? So we spend a lot of time making sure that ClickHouse could integrate with Kafka, Red Pandas, MySQL, PostgreSQL, and various data lake, Delta, Iceberg, Parquet, Avro, JSON, whatever you name it. ClickHouse is probably an integration for it. But yeah, our main secret sauce is really how we are doing low query latency on top of our own storage. But recently, we saw a strong interest in data lake technology. How do we query Parquet file? How do we query Iceberg tables? So obviously, when there's a lot of people using Parquet files and Iceberg table, we see attraction from the community to actually use it as well in ClickHouse. And if we're looking back, I don't know, 4 years ago, the first pull request around Iceberg was contributed by the community. It was a ClickHouse user that wanted to also use Iceberg with ClickHouse. And that where the support for Iceberg in ClickHouse started to be created. And as you know, ClickHouse really focus on performance. So every release, every night, we are testing ClickHouse, and we are making sure that on a variety of benchmarks, the latency always go down. So that's really a big focus for us. And today I'm going to talk to you about basically how can we make ClickHouse fast, not only on top of its own native format, but also on top of different format, which will be here, Iceberg. That's kind of one of my priorities this year, is trying to improve the performance of ClickHouse on top of Iceberg, because performance today is really what matters, right? Regardless of the storage you're using, people want more interactive data. They want to use agents, right? And an agent doesn't write a single query. It writes tens of queries. And you can see that the cumulative aspect of all these queries that are written by an agent matter to have like a interactive experience. So how do I achieve the same level of speed on top of Iceberg? And to give you an idea of the performance comparison between ClickHouse native format and Iceberg, this is kind of a diagram that I like to use to illustrate that. So in yellow, this is the performance of the same benchmark on top of ClickHouse native format. In gray, it's the performance of ClickHouse on top of Iceberg format. So you can see that for cold performance, ClickHouse is relatively faster, maybe 2 times faster. Where we are really seeing a big difference is, for hot query, where ClickHouse really outperform Iceberg. So how do we close the gap between this bar? Like, how do we get the gray bar to be at the same level than the yellow bar? And that's kind of the task that I've been given to, which is almost impossible, but I'm going to try to make it as small as possible. So if you want to understand how we are doing it and how we are, thinking about the problem, you need to understand how Iceberg table is basically read, right? So if you are not familiar with an Iceberg table, I'm here, like we're an Iceberg meetup, so I'm going to be very brief, right? So an Iceberg table is basically just a set of, metadata file and a set of data file. And sometimes, not always, they are behind a catalog, right? So you want your query engine to be able to connect to a catalog and eventually being able to read this metadata file as efficiently as possible, and then read this data file as efficiently as possible, and then parse the results, process the query, and return a response to the client. So there is a lot of steps that we can actually improve over time, and I'm going to talk about a few optimizations that we implemented on the ClickHouse side. But before I dive into this optimization, the first thing that we had to do when we started building this integration with Iceberg is making sure that we have enough introspection, right? Because when you want to work on optimization problem, you need to make sure that you understand what's going on when you are querying an Iceberg table. So we spend a lot of time like adding a bunch of metrics in ClickHouse whenever we are querying an external table to try to monitor everything that is happening. How many manifest file did we read? How many Parquet file did we read? How many pages in the Parquet file did we read? So we collect all these metrics, and that can help you understanding how efficient your query engine is on formats. So this is an example of how to use it in ClickHouse. So now the first thing that we did to improve performance on top of Iceberg is to rewrite our whole Parquet reader, right? So historically speaking, we had our first Parquet readers and we had a second one. And we were like, oh, we don't have enough Parquet reader in ClickHouse. Let's create a third one. Because, engineering is not always like, I will say, a straight line, right? Sometimes you have to do, curve and seeing what's happening over there and say, oh, that's not so good, and then go back to your original idea. The main difference between our second Parquet reader and our third Parquet reader is in the second Parquet reader, we were using a Arrow library. So we are basically having like an intermediary format in between the Parquet file and ClickHouse interpretation of this Parquet file. So we completely removed that library, and now we directly read the Parquet file. And on top of that, we were able to leverage more metadata in our package file. So we were able to read, for example, all the Bloom filter and apply this Bloom filter to lower the amount of data that we had to read from this package file, which helped us get much better performance improvement. So you can see in light gray, that was with the Parquet Reader v2. In dark gray, it's a Parquet Reader v3. Depending on the query, we saw performance improvement varying from 20% improvement to 40% improvement, which is quite significant. So that's the first thing that we did. Then the second thing that we did, of course, was to improve our caching layer. So when you work with Iceberg table, there is tons of information that you need to be able to process. And one of them is the metadata file. And you spend a lot of time between the query engine to read all this metadata file and understanding which data file you actually need to read. Often this metadata file doesn't change, so it makes sense to be able to cache this metadata file. So this is an optimization that we also have added, is that ClickHouse can cache in memory all this metadata file and eventually add a staleness function. So after a certain amount of time, we check if this metadata file is still up to date. But that's one of the optimizations that we implemented. And again, it helped us closing the gap. So the way it worked is basically ClickHouse has a in-memory cache, right? At the first read, we go to our Iceberg catalog, we read a snapshot, we read the manifest list, manifest files, and we cache that in memory. We recently also introduced a way of loading this in-memory cache onto a disk cache for better memory management. And then we reuse this cache on the subsequent read. So that helps us improving performance because we just have to read the data file now. One optimization that we have recently implemented as well is that we asynchronously refresh this metadata file. So instead of relying on the user to say, okay, the cache has been stale, or we just every 60, this is a configurable setting, but every 60 seconds, for example, or 30 seconds, we are going to asynchronously fetch this metadata file into your Iceberg table and reload them into ClickHouse, so they are more frequently fresh, and you don't need to query this data file directly at query time. And another optimization that we just released, I think, the previous version, which I didn't talk about, is that so you have the metadata file for your Iceberg table, but in your Parquet file also have metadata information, right? They tell you information about where to start a specific page, which page match certain statistics, and they're contained in the footer of the Parquet file. And recently, ClickHouse introduced a new caching layer, which takes this footer of the Parquet file and put it into a caching layer. So when we read the same Parquet file, we can just check the footer of the Parquet file, and we know directly, based on this metadata information, which part of the Parquet file to read, which also help the performance quite a lot. I think the seen performance improvement is around 15 to 20% performance improvement when we can use this Parquet footer information. And when we worked on this implementation, a big chunk of of our work is to actually troubleshoot problems, because sometimes we detect that a writer is not really writing properly Iceberg tables. So we spend a lot of time actually wondering, what did we break? Is it us that broke something, or is it someone else that broke the Iceberg specification? So we also added a lot of troubleshooting functions. So for example, something that we use a lot is we try to understand, especially when we are reading a table that is not ours, what are the information that we need to read. So we added a setting that you can specify at your query time, and ClickHouse will basically track all the manifest files or manifest lists that it read to be able to replay later on. So we store that into a ClickHouse table. So for example, this is a setting that you can add to your query, and then you can check this query, and you can check all the file, and then you can go back in time and kind of go back to, okay, was a specific metadata file broken or not? Why, we couldn't use it to read the Iceberg table, and that helps us a lot doing introspection. So what is next for us to keep improving the performance of ClickHouse? So there's a bunch of optimizations that we already did. So for example, the Parquet metadata cache, we already did it. But there's features that I would like to implement is currently when you read an Iceberg table, the coordinating node will do all the reading of all the metadata file. It's not necessarily optimal because we can distribute the read of the Parquet file, but we could also eventually distribute the read of all the metadata information. So that's something, an optimization that I would like to implement. We would like to implement some query condition cache optimization with multi-stage preware, late materialization for Iceberg table. So we have a bunch of optimizations that are still pending to be implemented. And given that ClickHouse is an open source project, if you feel like implementing any of them, please reach out, and we'll be more than happy to work with you and provide you guidance on how to contribute to this project. Anyway, that was kind of a small summary of all the work that we are doing at ClickHouse. Just around, for example, supporting one more format on top of the 70 other formats that we support. If you have any question, please fire away. And if you are too shy, you can scan the QR code and ask me later.
See the opportunity to ask directly. Any questions to Melvin about Iceberg or other 70 formats? Everyone is shy, tired? Oh, got it.
Yeah, in the hot case, what is the biggest contributor for the native format to be so much faster? Were you able to identify that?
So I think one of the main differentiators is that ClickHouse is really using its resources as much as it can, right? So it's going to load a lot of things in memory, including like a primary index, mark caches, which you will not necessarily cache using an Iceberg table. So ClickHouse has, I will say, a much more advanced caching layer compared to Iceberg. And also the way our caching layer works, like it has been designed for ClickHouse native format. And then we have a second implementation of the file system cache for external formats. And this caching layer is not necessarily optimal. It's just like break down files based on a certain number of bytes. And I think for Parquet, in particular, we could do smarter breakdown on how we break down the file and cache it. We could, for example, do the caching based on the page layering of a Parquet file, which we do for ClickHouse, but we don't do for external formats. Question?
Does the data stay within the in-memory cache, or do you guys also add it to the merge trees and like the ClickHouse?
Yeah, no, when you read a Parquet file, it stays there. Like we just cache some metadata, but we don't cache any other things, or we don't index anything when we read an external table. Yes.
Well, thank you, Melvin, again.
Thank you.
Very nice stuff. So we guys came actually to the end of the active part. So I wanna say thank you to everyone who was presenting today, and thank you for ClickHouse and for Google providing that venue. We still have some time till 9 to use the time for a networking, so don't run away. Just have a conversation, try to digest everything what was explained. We had like great talks about Ducklake, ClickHouse, about like how you can actually survive the whole story, what's about the data contracts and how to use the data mesh maybe in that sense. Therefore, thank you again to be here, to be part of that community. Stay further, be the next time here on stage and present your case. It will be nice. Thank you very much.